Key performance indicators, KPIs, are essential for evaluating the performance of a software quality assurance (SQA) team and its individual members. The right KPIs help ensure the quality of the product, optimize processes, and improve overall team efficiency. Here's an extensive breakdown of relevant KPIs for both the team and individuals within an SQA context. KPIs for evaluating SQA team performance. 1. Defect detection efficiency, DDE, definition, measures the effectiveness of the team in detecting defects before the software is released to production. Formula, DDE equals number of defects detected during testing / total number of defects, testing plus production, times 100. Purpose, a higher DDE percentage indicates a more efficient team at identifying issues before the software reaches production. 2. Defect leakage, definition, measures the number of defects that were not identified during testing but were found in production. Formula, defect leakage equals number of defects found in production / total number of defects times 100. Purpose, helps evaluate the team's ability to catch critical issues before release. A lower defect leakage percentage reflects better quality control. 3. Test coverage, definition, refers to the percentage of the application code, functionality, or scenarios that have been covered by tests, manual or automated. Formula, test coverage equals number of executed test cases / total number of testable items times 100. Purpose, ensures that the team is adequately testing all parts of the application, leading to fewer untested features and fewer bugs slipping through. 4. Defect severity index, definition, measures the impact of the defects found based on their severity. Formula, defect severity index equals sum of defect severity / total number of defects. Purpose, a high defect severity index can indicate that the team is missing critical or high-impact bugs, which may point to inadequate test strategies or insufficient test coverage. 5. Test execution productivity, definition, measures the number of test cases executed within a given time frame. Formula, test execution productivity equals number of test cases executed / test execution time, in hours. Purpose, helps in evaluating the efficiency of the testing process. A higher productivity rate shows that the team is working efficiently. 6. Defect turnaround time, definition, measures the average time taken to report, resolve, and retest a defect from the time it was discovered. Formula, defect turnaround time equals total time taken to resolve defects / total number of defects. Purpose, shorter turnaround times reflect how quickly the team and developers are addressing issues, which is critical in fast-paced environments like Agile or CI/CD. 7. Test automation coverage, definition, measures the percentage of test cases that have been automated versus manual tests. Formula, automation coverage equals number of automated test cases / total number of test cases times 100. Purpose, higher automation coverage often correlates with faster testing cycles and more efficient regression testing, enabling quicker releases and reducing human error. 8. Test case effectiveness, definition, measures how well the executed test cases are identifying defects. Formula, test case effectiveness equals number of defects detected by the test cases / total number of executed test cases times 100. Purpose, a higher percentage indicates that the test cases are effective in detecting defects and the test strategy is aligned with the software's potential failure points. 9. Time to release, definition, measures how long it takes for the software to pass through the entire testing phase and be ready for production release. Purpose, a shorter time to release indicates a streamlined process and a more efficient team, while maintaining high quality. 10. Bug fix rate, definition, tracks how many bugs are resolved in a given time period, especially in comparison to the number of reported bugs. Formula, bug fix rate equals number of bugs resolved / total number of bugs reported times 100. Purpose, a higher rate shows that the team is proactive and efficient in resolving defects. KPIs for evaluating individual SQA performance. 1. Defects found per tester, definition, measures how many defects an individual tester finds during a given period. Purpose, provides a basic metric for the productivity and attention to detail of each tester. More defects found indicate better performance. 2. Defect quality index, definition, measures the accuracy and relevance of the defects found by a tester. Purpose, if an individual is reporting many low priority or invalid defects, it may indicate the need for better understanding of the system or more targeted testing. High priority, valid defects suggest stronger performance. 3. Test case design efficiency, definition, measures how quickly and effectively a tester can design and create test cases. Formula, test case design efficiency equals number of test cases created / test design time, in hours. Purpose, assesses the tester's capability to produce high-quality test cases quickly, which is critical in Agile environments. 4. Test execution rate, definition, measures how many test cases an individual tester executes in a given period. Formula, test execution rate equals number of executed test cases / total number of test cases assigned. Purpose, helps identify individual productivity in terms of how many tests are run and checked. It's important to monitor this alongside the quality of the defects detected. 5. Defect rejection rate, definition, measures the percentage of defects reported by a tester that are rejected by developers due to being invalid or duplicate. Formula, defect rejection rate equals number of rejected defects / total number of reported defects times 100. Purpose, a lower rejection rate means the tester is filing valid and useful bug reports. A high rejection rate indicates that the tester might need more training or better understanding of the application or requirements. 6. Defect retesting efficiency. Definition: measures how effectively the tester is retesting fixed defects and verifying the solutions. Purpose: retesting is as important as finding defects. A tester with a high retesting efficiency ensures that fixed issues do not regress or cause new problems. 7. Time to raise defects. Definition: measures how long it takes for a tester to report a defect from the moment it is first encountered. Purpose: quick reporting of defects can shorten the feedback loop and improve overall development speed. This KPI ensures that testers are not sitting on defects but are reporting them promptly. 8. Automation scripting efficiency, if applicable. Definition: measures how many automation scripts a tester writes and how effectively those scripts contribute to test coverage. Formula: automation scripting efficiency equals number of automation scripts created / total hours spent on automation. Purpose: measures individual contribution to automated testing. Faster creation of reusable and effective scripts indicates high competency. 9. Collaboration and communication. Definition: evaluates how well the tester collaborates with developers, product owners, and other team members. Purpose: particularly in agile environments, effective collaboration is essential. This KPI can be subjective but is often measured by peer reviews or 360-degree feedback. 10. Test documentation quality. Definition: measures the clarity, accuracy, and completeness of the test documentation, e.g., test cases, bug reports. Purpose: good test documentation is critical for knowledge sharing and traceability. This KPI ensures that testers are maintaining high-quality records of their testing efforts. Qualitative KPIs, soft metrics. While the KPIs listed above are quantifiable, there are also qualitative KPIs that are critical for assessing both team and individual performance. These often involve feedback from peers, stakeholders, and self-assessments. 1. Adaptability to new tools and technologies, especially relevant when introducing new test automation frameworks or tools. Teams and individuals who are quick to adapt and learn demonstrate value in fast-paced environments. 2. Innovation and initiative, the extent to which individuals or teams introduce new ideas, strategies, or testing methods to improve processes and find defects more effectively. 3. Problem-solving skills, particularly in cases where bugs are complex, testers who exhibit strong problem-solving capabilities are invaluable. Tips for implementing and using KPIs: set realistic targets. KPIs should be challenging but achievable. Unrealistic expectations can demotivate the team and negatively impact the quality of the work. Regular reviews and adjustments. KPIs should be reviewed regularly and adjusted based on project needs, team performance, and changes in the development process. Balanced scorecard. Avoid relying on a single KPI. Use a combination of performance, quality, and collaboration metrics to get a holistic view of the team and individual performance. Automation versus manual testing. If both manual and automation teams are involved, separate KPIs for both approaches should be considered, as their performance metrics often differ. Continuous feedback loop. KPIs should inform both management and testers, fostering continuous improvement in performance. These KPIs, when correctly implemented and monitored, provide invaluable insights into the overall performance of the QA team and individual contributors, ensuring that software quality remains high throughout the development cycle.